this man is standing in a lift, and the lift is doing absolutely nothing. In other words, the lift is stationary. We, I'm sure, can all agree that he might as well be standing on the floor. And if we then want to know what is the reading on a scale that he's standing on, it's a Newton scale, it's going to be 82 kilograms times 9,8, and we're going to land up with 803,6 newtons. In other words, it's exactly what it would be if he wasn't moving at all. The truth of the matter is as well that if this lift was moving at a constant speed, any constant speed, up, down, no matter what, if it was at a constant speed, there are no unbalanced forces. There's no acceleration. Without acceleration, we can't get a force resultant because force resultant is equal to mass times acceleration. If there is no acceleration, there is no unbalanced force. And therefore, the reading on the scale when there's a constant speed or a constant velocity is also going to be 803,6 newtons. But what happens when I now decide to speed this lift up or slow it down? So this lift is now accelerating upwards at 2 meters per second squared. So there is a force being exerted by the man. The whole lift is exerting a force onto the man of 2 times his mass. It's an unbalanced force onto the man. Simultaneously, the man exerts an equal but opposite force down onto that pink line would be a scale onto the scale. In other words, we are going to add, if I am accelerating upwards at 2 meters per second squared, I'm going to take the weight, which is the one downward force, and the other downward force onto the scale is this unbalanced force as a result of the movement of the lift. So I am going to say 803,6 newtons plus the unbalanced force of 2 times 82. And I land up with the reading of the scale of 967,6. Now I want you to close your eyes and imagine a lift pulling off upwards underneath you. So if that lift is suddenly pulling off upwards, you feel heavier. This 967 is greater than the normal 803. You feel that downward force that you push onto the ground. You feel like you're bearing down onto the ground. If I now am going to accelerate this object downwards, so now the lift exerts a downward force on the man, because the lift is going down, the man will have an upward force from the lift, which means that I'm going to actually subtract that portion of the force from his normal weight. His normal weight will be 803,6 minus 164, which remember was 82 times 2. And I land up with 639,6 newtons. Think about it again. Close your eyes and imagine that a lift is at the top floor and it starts going downwards. It accelerates downwards. At that point, you feel like you've left your stomach up behind and you feel much lighter. You feel much lighter. 639,6 newtons is much less than 803,6 newtons. So here you can see how we've got action-reaction pairs that are going to be added or subtracted onto your normal weight when you are moving up or down in a lift.